EV Expert, e-learning, diagnosis. Inverter capacitor. Overview. Unlike internal combustion engine vehicles, electric vehicles have power electric, PE, to operate motors using high voltage. PE consists of a motor, reducer, OBC, EPCU, and high voltage junction block. EPCU, the integrated control module of an electric vehicle, consists of VCU, MCU, inverter, and LDC, and the capacitor is equipped in the inverter of the MCU. If the power of the high-voltage battery is not stably supplied to the motor, a problem of vehicle driving may occur. The capacitor temporarily stores the electric power of high-voltage battery and discharges it to compensate for the temporary shortage of power supply in situations such as sudden acceleration. It also prevents damage to high-voltage components, which can occur due to the influx of surge voltage generated by the drive motor. Then, let's take a look at the capacitor in more detail. Inverter capacitor. Residual voltage measurement. The electricity stored in the capacitor will be discharged within 1 second after EV off by outputting high voltage to the drive motor coil. So in normal vehicles and in normal circumstances, EV off state will completely remove the vehicle's high voltage. However, in the case of vehicles damaged by an accident or defect, the vehicle may not operate normally. So, it is critical to check whether the high voltage has been completely removed to prevent accidents. Then, how can the cutoff of the vehicle's high voltage be checked? Turn off the vehicle. Caution: conduct work according to high voltage maintenance procedure. Disconnect the 12-volt auxiliary battery minus cable. Remove the service interlock. Remove the rear seat bottom from the vehicle. Remove the service plug. To secure high voltage self-discharge time, check whether 5 minutes have passed after the service interlock and service plug have been removed, and then disconnect the high voltage cable. Capacitor discharge check. Let's now measure the voltage of the high voltage cable side. If the voltage is less than 30 volts, the inverter capacitor is safely discharged. Also, check whether the voltage of the high voltage battery side is less than 30 volts to ensure the normal function of the PRA. Measuring capacitor voltage with GDS. Let's measure the capacitor voltage using GDS. Select Data Analysis. Select BMS. Select BMS Main Relay On Status to check the main relay status of PRA. Battery DC voltage to check the HV battery output voltage. And inverter capacitor voltage to check the capacitor voltage that is the most important checkpoint. It is confirmed that inverter capacitor voltage is same as battery DC voltage. This means that the main relay is turned on and the voltage of the high voltage battery is charged in the inverter capacitor. Now, let's remove the service interlock. When the service interlock is removed, the main relay is turned off immediately. At the same time, it may be confirmed that the inverter consumes the residual voltage of the capacitor. However, in case the residual voltage of the capacitor still remains, it is necessary to secure a time for the capacitor to self-discharge. Therefore, please wait for more than 5 minutes and then measure the voltage safely.